Okay, so now we come to this problem where we have planes flying from Cleveland. Now, there's a lot going on in this problem that has to do with future classes in calculus and in physics. First thing you realize is that my plane that's flying west from Cleveland is traveling at 350 miles per hour, and a second plane that is traveling 5 degrees south of southeast, which is approximately here, and we'll get the actual angle in a minute, is traveling at 200 miles per hour. But I can't actually use these because this is a velocity and this is a velocity, and they want me to know how far apart the planes are as the goal. So if I use these, I would find how fast they're separating apart from each other. I would not find their distance. So I need to use this direct variation problem from Algebra 1 or possibly introductory middle school physics, which you learn in 7th or 8th grade, that distance is rate times time. So I take the rate of 350 miles per hour and I multiply by the time given me, which is 1 hour and 36 minutes. But of course, that is not put into units, right, that are appropriate because it needs to be in hours. Notice the hours here and the minutes there. So I need to convert the 36 minutes into hours by dividing by 60. So it's 1.6. I could also, in turn, take 36, add it to 60 because it's 1 hour and 36 minutes, and then divide 96 by 30, and I get, by 60 minutes, and I get 1.6. So I take 350 times 1.6 and 200 times 1.6, and I get the actual mileage, and that's just a straight multiplication, as you can see, no big deal, pretty easy. Direct variation means multiply by one thing, done. To do the other one, right, same thing, multiply by one thing, and done. So what I actually put on here is I actually put on their mileage that they've traveled. That going that fast at that amount of time is that much, and this one is 320 miles. So the question is, how do I figure out this angle right here, right? I need to figure out this angle because you can see what they're actually wanting me to do is find the distance between these two planes here. And so the way that I do that is I come up to this problem and I take a minute and I draw this out. Okay, so let's talk about what's going on here. Southeast is a dedicated measurement in the universe of 45 degrees. And then it wants me to go 5 degrees south of that. Okay, so if I take these two together and get 50, I would get 50. And that would give me the measurement in here. But that's not like the planes aren't over here. So I have to find this linear pair, right? So I take 50 and I find the linear pair over here, which would be 130. Linear pairs are supplementary, so 130 is supplementary with 50 degrees, giving me this total of 180. And so now to finish the problem off, your distance squared will be equal to 560 squared. And then the rest of that law of cosines, just don't forget to use cosine, use 130, and don't forget to take the square root. And so you start to see why the law of cosines is so important, because it finds these distances that are kind of, really when you think about that, it's kind of just like up in space in the air somewhere. Very useful, but a little bit more involved.